Distinguished guests, it is my pleasure to introduce NAE Executive Officer Al Romig.
Good morning, everyone. Waiting for a few of the last-minute attendees. Very good. Well, welcome to the Forum on Engineering the Future of Sustainability. I would like to begin by putting the term sustainability in context, as it means different things to different people. As engineers, we look to the United Nations 17 sustainability goals to guide our understanding of sustainability. These goals include the end of poverty and hunger, the development of clean water, sanitation, affordable and clean energy, responsible consumption and production, industry and innovation, and social aims like peace, justice, gender equality, well-being, and quality education. Now, none of those are objectives of engineering, but every single one of them can be facilitated and enabled by advances in engineering. The challenge with these goals is that measurement is needed in order to ensure progress. We all know what gets measured gets done. So what are the best measurements to use to assess progress towards sustainability? How do we best measure the cradle-to-grave impacts of sustainable technologies? Life cycle analysis, LCA, is one broadly used methodology. What are some of the others? Can we develop better tools or metrics for charting progress towards sustainability? In this forum, we will investigate these questions. With the help of our moderator, Deanne Bell, today's panelists will explore how we engineer sustainability, how we measure it, and how we gain society's buy-in of what defines progress towards creating a sustainable future for our planet. The speakers today bring enormous value to this issue. Arun Majumdar, our plenary speaker, will remain with us during this panel. And we are grateful for the opportunity to hear from David Allen, Sarah Kapnick, and Erkan Erdem as well. Before I introduce Deanne Bell, I would like to also thank our internal staff, Michaela Kern and Kim Middleton from our membership office, Eileen Erickson and her team from communications, as well as our organizing team that pulled this together. You can see their names in the program. And a special thanks to the chair of the President's Business Advisory Council, Tom Degnan, and the chair of the working group, Ann Roby. Now, I'd like to introduce Deanne Bell. She's moderated this. I think this is your fourth year for doing this, if my memory's right. Could be fifth. Maybe fifth. Somewhere around that. Sure. Yeah. She's a mechanical engineer, television host, and entrepreneur. Her TV hosting credits include PBS, ESPN, Discovery Channel, National Geographic, DIY Network, and CNBC's Make Me a Millionaire Inventor. She is also the founder and CEO of Future Engineers, an education technology company that engages students in online contests and challenges. Recently, her company was selected by NASA to host the Mars 2020 Name the Rover contest. Previously, Deanne worked at Raytheon for 3 years as an optomechanical engineer, and she earned her BS in mechanical engineering at Washington University in St. Louis. And rumor has it, but it is not a rumor, I've self-seen this, she will carve up the dance floor tonight at the dinner dance. Deanne?
Thanks so much, Al. And thanks. It is an honor to be here again, and welcome to the 2023 National Academy of Engineering Annual Technical Forum. As Al mentioned, this year's theme is Engineering the Future for Sustainability, Measuring and Communicating Our Progress. And I'd say, one of the things I look forward to most every time I come out to this meeting is the power of a meeting, the power of convening, the power of having, our nation's most brilliant minds all in a room, all with different expertises, to have these conversations, to have, to deep dive into these different areas of expertise and to ask the tough questions. And so we're going to leave a lot of time for questions here. So as these questions are brewing, make sure to keep them up here and we'll take as many as we can. But as Al mentioned, what sustainability means to each of you and your varying fields of work, your varying personal lives, your varying consumer habits might be very different. And I think there's an urgent need for us to take a holistic approach, as Arun mentioned earlier, and to really think about how we can address these topics together, how we can measure them collectively, and how we can communicate that for societal buy-in for going towards a more sustainable future. So I'm really, really honored to be joined here on stage with some of the engineering and scientific community authorities on sustainability, tools for measuring sustainability, and societal acceptance. I'm joined here by Sarah Kapnick, who's the chief scientist at NOAA, the National Oceanic Atmospheric Administration. And she's going to be discussing decision support and innovation to understand risks and opportunities. And then next, we also have a panelist, David Allen, who's the Norbert Dietrich Welch Chair in Chemical Engineering, the Director of the Center for Energy and Environmental Resources, and co-director of the Energy Emissions Modeling and Data Lab at the University of Texas at Austin. And David will be speaking about measuring, reporting, and verifying product sustainability metrics. And then next, we have Erkan Erdem, who is the U Partner and National Leader of Economic Services Practice at KPMG, and he'll be speaking about how tools and methodologies can support sustainability decisions. And of course, you guys all heard from Arun Majumdar earlier, who's also joining us as a panelist today and is excited to take many questions as well. So the way it's going to work today is we're going to hear from each of our panelists for about 8 to 10 minutes. With their presentation of their slides. And then after that, we're going to open it up to the audience to take your questions on sustainability. So first, we're going to start here right next to me with Sarah Kapnick. So Dr. Sarah Kapnick is responsible for guiding the programmatic focus of the National Oceanic and Administration's science and technology priorities. Previously, Dr. Kapnick served as a physical scientist and deputy division leader at NOAA's Geophysical Fluid Dynamics Laboratory. Her work spanned seasonal climate prediction, mountain snowpack, extreme storms, water security, climate economics, and climate impacts. Most recently, she served as managing director at JP Morgan, functioning as senior climate scientist and sustainability strategist for asset and wealth management, supporting sustainability and climate action efforts, and serving as an advisor on new business and investment opportunities and risks. Additionally, she co-founded a renewable energy forecasting startup and has held positions at a voluntary carbon registry and Goldman Sachs. Dr. Kapnick earned a PhD in atmospheric and ocean sciences from UCLA and an AB in mathematics from Princeton University, and has received numerous awards, including the NOAA Albritton Outstanding Science Communicator Award. Thank you so much for joining us here today.
Thank you so much for having me. I'm so happy to be here. So I am coming with the perspective of NOAA. From NOAA, we have ships, satellites, radar, weather stations, autonomous vehicles cruising through the ocean as well as through the atmosphere. We also have aircraft that fly into hurricanes on the East Coast and the Pacific, as well as atmospheric rivers, and also take measurements of air pollution around the country and around the world. So with all this information that we're constantly gathering, we are also putting it, recombining it back together, combining it with other data sets, and using heavy computational analysis to be able to unlock insights into that data and information. So in the picture here, we have a picture of a supercomputer. We also have an AI center that is increasingly being used to advance how we recombine all that data and move forward for our predictions, our projections, our forecasts of information looking into the future. So coming from NOAA, we are constantly measuring the globe. We put out a monthly global climate, state of the climate report. This one is from July, showing it was the hottest summer on record. July exceeded previous records by 0.3 degrees Celsius. August exceeded by 0.5. Usually we only break those records by 1,000th of a degree. We broke them by 10ths of a degree. It was a massive amount that shocked even the climate and data scientists that were doing this research, that we broke the records with just tremendous force. So it's getting hot. It's that heat around the globe. Part of the reason we're having it is an El Nino is developing, but also because of marine heat waves around the world. Almost 50% of the world's oceans are currently experiencing a marine heat wave. And with that, there are impacts. NOAA, through our National Ocean Service and National Fisheries Service, we have obligations to be able to monitor the ocean and monitor marine life in the ocean. The bottom picture is where the marine heat waves are occurring, but that's also our bleaching. It is the Coral Reef Watch, where we're watching how ecosystems are doing. And in the Caribbean and parts of the Florida Keys, we've been on bleaching events for multiple months. So the corals, the animals have left, and if it prolongs, they could also lead to death of the corals. So we're constantly monitoring around the world all the different physical, chemical, biological impacts of the environment, of climate variability and change. So with that, we also have developed science around understanding changes in probability. So we're measuring events, measuring their likelihoods, and understanding how that's changed over time. Over the last 10 years, there's been a tremendous amount of science advancements in this field of being able to attribute climate change to the changes in events. In our global report, we also map out every month where these events are happening around the world that are of note. And so we've had heat waves this past summer. There have been hurricanes, extreme precipitation and flooding, flash floods. There's also sea ice is at record lows in Antarctica and also at a low in the Arctic. So with this changing environment, it's not just the physical, biological, chemical that we monitor. We also monitor billion-dollar disasters in the United States. So since 1980, whenever we have a disaster that reaches $1 billion, we are taking a measurement of that, the type, as well as the costs and the distribution of those costs. And so this figure, those bars are the number of billion-dollar disasters in every single year, sorted by the different types, as well as the costs over time. And so both the number and the costs of these events has been growing over time. This summer, we've already reached $23 billion disasters, which is actually more than we've ever had in an entire year, and the year is not done yet. We also, affecting this, we have an El Nino developing. There's less than 1% chance now that an El Nino will not develop and last through the season. Less than 5% chance. And there's a very high likelihood that this El Nino could actually reach the strength of the previous 97, 98. And so looking into the future, we know that there's going to be more of these events coming in the coming months. There's going to be heating. And also from that, we have seasonal forecasts that look into the future about what is global temperature, what is that likelihood over time of temperature, precipitation, these other metrics. And from our forecast in July, we found that there's actually likelihood that over a few months we may exceed 1.5 degrees Celsius for a couple of months as this El Nino peaks. So we have all this information of what's been happening, near term what we expect, and then we also have projections of the future. So on the left sides of the charts is the expectations for sea level rise. We expect another foot of sea level rise around most of the nation by 2050, 1.5 feet in some places that have subsidence or in the Gulf Coast states. And we put all this information, it's all available on the Sea Level Rise Viewer, but also resilience.climate.gov through the Climate Mapping and Resilience and Adaptation tool that was launched by the Biden-Harris administration last summer and is hosted by NOAA. It has all this information available for download across the United States, what we're expecting, what we're seeing, and what we project into the future. So we have all this information. About what the near term, what's happened in the past, the near term, and what's happening into the future. We also translate that into damages and costs that we're seeing as well. With expectations for that growth in the probabilities and magnitudes of extremes and the potential for that increase in costs, we need to build a climate-ready nation to be able to have resilience in the face of these events. That's the only way that you reduce those costs. So with that, last week, the Biden-Harris administration hosted the first ever White House Climate Resilience Summit, and also released the first National Climate Resilience Framework. And so this is a pathway to building resilience, to reducing those costs and those impacts. Much of the sustainability to date has also been focused on decarbonization efforts, and measuring progress in some ways is easier for climate mitigation. It's avoided, reduced, or removed greenhouse gases. Measuring progress, however, towards climate resilience requires many different metrics. It requires flood-resilient buildings, extreme weather-resilient grids, outage days reduced, adaptation plans being implemented. So there's a number of things that need to be done to build out our ability to measure that going forward. So with that, I wanted to comment on, there's multiple reports through this administration that have been focused on how do we start measuring the economic effects of climate change. So there's a report that was done by the Congressional Budget Office by OMB. There's also a roundtable by the National Academies to bring climate information into macroeconomic models. So this research has not been done at the speed of innovation that we need, and so there's a major focus on trying to speed that innovation of measuring the financial impacts of all these climate issues. There's also in the March report to the President of Economic Report came out with an entire chapter, roughly 80 pages, of all the different opportunities and needs to building and understanding quantifying, but then also building resilience financially to climate change. So with this, NOAA, some of the things that we focused on, with NSF, we created a research center in response to insurance needs to bring climate information into catastrophe modeling. We held a series of roundtables. We hold a monthly webinar where we talk about the latest in science that can translate into insurance. And coming out of this, it came a question from the industry of we need workforce development and we need new tools that include climate change. So we developed this center, and we'll announce it in the coming months, the centers that we will be funding, to be able to bring new climate projection information into insurance models, but also to now train the workforce that can do that going forward. Additionally, we've created other partnerships because all of this is the recombination of information we have on climate, weather, and the environment with other information to be able to have impact. So one, we have an agreement with the American Society of Civil Engineers to bring climate information into building codes. So if building codes are built to the current but also expected future climate, you build that resilience, you reduce those damages. We're also working with Microsoft on being able to combine AI with all of our data to be able to track marine mammals in the ocean and be able to do work on fisheries. And then the last one I put on here was we have another MOU with EPRI, which is the think tank for all of the utilities, to be able to bring information into how do you build resilient grids to weather and climate. So with all this information, there's also work that needs to be done on the biodiversity issues and nature capital as well. And so we're also launching over the next 15 years a movement towards creating the environmental economic decisions around nature capital. How do you create the accounting for that? How do you measure it? How do you measure it so you can use it going forward? Additionally, one of the last things I wanted to touch on is from all of this, there's also major new projects underway to bring whole of government into how do we measure issues and impacts around climate. And so one of them is a partnership through NIHIS, which is NOAA, CDC, EPA, HUD, FEMA, Veteran Affairs, U.S. National Park Service, DHS, among many, many others. And this is on heat.gov. It has all the information about heat, current heat, but expected future heat. And the reason it's all of government is because we can measure what expected temperatures and humidities are today and into the future, but then building those resilience plans requires all those different agencies to figure out how it affects their operations and how they can work with communities to build those adaptation plans and then implement them into the communities. And so a lot of this work requires a lot of interdisciplinary, transdisciplinary work to be able to do the measurements and then have impact to reduce what those impacts will be going into the future. So thank you.
Great, thank you. I think we're hearing yet again with what Sarah talked about, this interdisciplinary effort, and I know Arun mentioned it earlier as well, just this holistic approach. There's no sector that doesn't have an angle of sustainability that we need to figure out and we need to tackle and figure out how we can do that collectively. So I'm really excited. Thank you for setting the stage with that great presentation. I'm excited for you now to speak, to hear from David Allen. Dr. David Allen is the author of 7 books and more than 300 papers, primarily in the areas of air quality, greenhouse gas emissions, the engineering of sustainable systems, and the development of materials for environmental and engineering education. He served on a variety of governmental advisory panels, and from 2012 to 2015, chaired the U.S. EPA's Science Advisory Board. In 2017, he was elected to the National Academy of Engineering as a fellow member, and in 2020, he received the ENI Energy Transitions Award in recognition of his work on methane emissions from oil and gas systems. Professor Allen earned his BS in chemical engineering from Cornell and his MS and PhD in chemical engineering from Caltech. So it's my honor to introduce Dr. David Allen. You can take it away.
Thank you. So I'd like to continue the theme of looking at data measurements, and communication by talking about measuring, reporting, and verifying the sustainability attributes of our engineered systems, particularly products. And to do that, I'm going to use a specific example. I'm going to use the example of natural gas, so an energy product where the goal is to differentiate that natural gas based on its emissions associated with its production and getting it up to the point of use. So why might you want to do that immediately and at a global scale? Well, there are a number of marketplaces, principally among them the European Union, but also Singapore, many places in Asia, that are demanding natural gas produced with low greenhouse gas emissions, with a focus in particular on methane emissions. So why methane? Well, methane's the principal component of natural gas, and globally, from the point at which it leaves the ground at the wellhead to the point at which it reaches the burner tip, its combustion, about 2% of the methane escapes the system, leaks out. And as you heard this morning, methane is a potent greenhouse gas. If we take the potency over a 20-year period, the 100 teragrams a year from energy systems of methane that are emitted are the equivalent of 8 gigatons a year of carbon, so the equivalent of billions of cars on the road. And this is something that we can reduce immediately, and it would be the equivalent of removing the carbon dioxide emissions from billions of cars. So a really high-profile, short-term product. How do we put measurement and verification and reporting into that? Well, one of the problems with it is that the signal we're trying to detect, these emissions, are really complicated. So I'm showing you, if we could look down on one of the production regions in Texas and look with an hourly resolution at what the emissions are, this is what we would see at methane. 20,000 or so wells out of the 500,000 in the United States. This is what it would look like. There's no measurable feature of that methane coming through the pipeline that you can measure and say, what were the emissions along its supply chain, along its life cycle? So how do we do this? Well, the bad news is that we have this very complex problem. The good news is that we have data systems like NOAA's data systems and other data systems, advances in remote sensing, data analytics at a global scale that make high-resolution measurements and reporting possible. Right? What are some of those? There are aircraft equipped with LiDAR sensors. There's drones. There's people out at individual sites making measurements. There are permanent fixed sensors. There are satellites. There are various types of aircraft flying around getting us data. There is an explosion now of data. So how do we take all this, make it all consistent, do it transparently so that it's credible, put it into a life cycle framework, into a supply chain framework, and then report it and get it into global markets, and then do an independent verification. A challenging system, but we have all the pieces that can be engineered together. This is probably one of the most advanced systems that is out there because it's the biggest target in the short term, and the value of the product is large. So Academy's reports have made key contributions to understanding this sort of system. So back in 2018, there was a report on what are all these emissions, but then in 2022, the Academy produced a report that basically said, what do you need in these measurement and reporting systems? You need transparency, you need timeliness, you need rapid communication, you need a whole series of pillars that go into these global reporting systems. So there's also the question of who leads it. Right now, the US Department of Energy is leading the effort to bring in an international consortium of countries, of both importers of natural gas and exporters of natural gas, to agree to a global playing field. There are immense technical challenges on this, but the goal is big, and we can engineer these systems for measuring, reporting, and then independently verifying the sustainability features of our products. These are on the verge of development, but need guidance from organizations like the academies, and also need the work of engineers to put all these systems together. So one example of how we can put these sustainability metrics into our evaluation of products.
Great. Thanks. I know it was brought up earlier in the plenary, the need for a plan. It's a big question, but I think what you're talking about is really getting at the root of how we take all this complexity and how we simplify it. The next speaker we have, Erkan Erdem, is the U Partner and National Leader of Economic Services Practice, as mentioned. Dr. Erkan Erdem is an experienced economist with expertise in data analytics, program evaluation, policy analysis, econometrics, and financial modeling. He supports both government agencies and private clients with a variety of analyses and solutions, such as social impact analyses and climate risk assessments. Dr. Erdem supports leading law firms with economic analyses and has testimony experience in federal court. He's published in peer-reviewed journals and frequently presents at national conferences. He taught graduate-level econometrics at the University of Maryland as an adjunct professor for many years. Dr. Erdem earned a BA in economics and a BS in mathematics from Koç University in Istanbul and a PhD in economics from Penn State University. Take it away, Erkan.
Thanks, everyone. So I want to provide my perspective from the work I'm involved in with companies. Many of the concepts and databases Sarah and David mentioned actually are inputs to what we do for companies. All the fun part. All right, so sorry about that. I'm an economist and I'm involved in financial modeling as it relates to reporting of sustainability measures. I think here we talk a lot about emissions and climate change, but companies actually are getting ready to report on environmental, social, and governance-related measures. You may have heard of ESG. Many of the tools and databases Sarah mentioned are actually input to the modeling companies are relying on to report on their emissions. I wanted to just tell you a little bit more about the background for reporting, right? I mean, reporting for companies mean, compliance with laws and regulations. Many companies publish sustainability reports for a long time, but it was not based on a standardized set of rules. It was a report that existed on the website no one really looked at. What's happening lately is we're moving from frameworks that kind of give them a direction on what they should be doing to standards that are a little more prescriptive. And then the big change in the last at least 5 or so years is that we're moving from voluntary reporting of these data and information to mandatory. And Europe is probably ahead of us in terms of requiring companies to report on their ESG metrics. And you may be following that the SEC had a proposed rule on climate-related risks and opportunities last year, and it's expected to be finalized sometime in 2014. That's when all publicly traded companies will have to report on the financial impact of climate change, which is a big change for companies out there. So we're going from framework to standards, and then the regulators rely on these standards and require companies to report on ESG. And then we also have third-party providers out there that do rankings and ratings of ESG-related metrics. In terms of the current state of sustainability, I don't want us to be an acronym salad, but unfortunately so many acronyms out there. What we see in a survey of major companies in late 2020 is that GRI is becoming the choice of standards that companies rely on. It's a little ahead of the United States in terms of what % of the companies report on ESG-related metrics in South America, Asia, as well as Europe. Many of these include a long list of measures. For example, on the environment side, it would be about emissions, including scope 1, 2, 3 emissions, their impact on air and water pollution, waste management. On the social side, it's more about their diversity, equity, inclusion-related metrics, pay equity. Do they have gaps between males and females for the same roles, as well as a variety of HR policies. Many of these are demanded by investors and financial services companies. So stakeholders have more information when they make their business decisions or investment decisions. Governance is a little maybe less prioritized, but it's when companies report on their stakeholder powers, they report on their board structure, and so on. Related to what Sarah talked about, what's expected to become a requirement soon is the climate-related risks and opportunities in 2024, and then there will be a timeline associated with that. You may have heard of the Task Force for Climate-Related Financial Disclosures, TCFD, which has been the primary framework that companies relied on. It basically asks companies to come up with financial estimates for impact related to their physical risk and transition risk. So physical risk, for example, include data from NOAA. We rely on the Climate Adaptation Resilience tool, for example. We gather data from third-party providers on flooding risk, drought risk, wildfires, and so on, which become input to the financial modeling companies rely on to understand the impact on their assets, their infrastructure, as well as their business disruption. One of the challenges companies face here is additional prescription on what they need to do. They, for example, rely on insurance market a lot, and I think regulators will probably include a decision on that in their final rule. Being able to insure your assets is becoming more and more challenging in this uncertain environment, right? So you may not be able to insure your factory or facility in California for wildfires in the future, and same for hurricanes in Florida. What we see here is that transition risk is a little more challenging for clients. The easiest one to calculate and report on is carbon pricing related risks. So this is based on the commitment you mentioned. The expectation is that there will be a carbon tax or carbon price in the future, and that will have a significant financial impact on companies as costs. So it's easy to rely on data sources from IEA or IPCC or NGFS that give you an understanding of what the carbon prices may look like all the way to 2050. And then you come up with an estimate for what that financial impact would be if I have to pay for my carbon emissions. And all of the emission-related data gathering, reporting becomes an input to that. So it's all completing the same picture. What we see here is that there was a significant increase in reporting, even though it has been voluntary so far in the US and many parts of the world. There is still a lot of room to improve here for investors and financial services companies to have a better understanding of risks associated with climate change. And the TCFD framework, again, will become an important input for the SEC final rule next year. But the idea is that we will probably move away from qualitative disclosures to more quantitative disclosures that are based on these financial models and all of the data sets that become input to measurement. The last one I had here is more about the social related reporting for sustainability. Companies understand their actions, but they mostly report on process measures, or what we call process measures as economists, as opposed to outcome measures. We have been helping them with building economic impact studies so they get a better sense of their indirect and induced impacts in the economy as they make their ESG-related investments. But there is still room for them to better understand their societal impacts. For example, what's the impact of my products on the health of my consumers, right? It's not easy to measure, it's not required, it will probably not be required, and it requires a lot of custom work. So it's hard to press a button or an IT system and get your emissions, right, at the end of the year. So you need to understand, if you are in oil and gas industry, if you are in a tobacco industry, like what does that mean for your social metric or social rating? That's based on outcomes, but not process only. Models are still being developed also for government agencies, for them to have a better understanding of climate change on their communities. Again, this is more for policymakers to understand how, let's say, flooding will impact different communities by race and ethnicity, by income level, or vulnerable populations. I think our agencies are waiting for more guidance and more standardization for reporting on that. And that completes my comments. Thank you.
Great, thank you. So we are going to transition into a question and answer session. So at this point, if you have questions, feel free to go over to the microphones. As you guys know, Arun is also on the panel, and you heard his plenary earlier. So you're welcome to direct a question to any of our speakers here. But I'm going to talk first. I mean, I think, to be honest, the biggest takeaway here that I have is it's complex. It is very complicated, and there's a need for standardization. There's a need for us to address this in an interdisciplinary way. There's a need for us to come together and agree on how we measure these things. And, from my experience as a science communicator, speaking on TV, when I think about the simplicity of communication, it's getting to a point of like, I buy a product, there's a sustainability score, I know what to do. I'm a company, I'm the CEO of a company, like I have a sustainability report that I need to do. I know that formula. How do we get to that point of simplicity, of clarity, of cohesion? In your respective work, what do you think is one of the largest priorities that we need to tackle to kind of come together to get to a point of simplicity, clarity, agreement? I'm going to start with you, down at the end, Arun.
With me?
Yes.
Well, how long do we have? Well, first of all, I think the measurement part is super important. The methane measurements, as Dan was talking about, there are methane SAT that is going up now with the Environmental Defense Fund in collaboration with academia. There are, as you pointed out, drone-based measurements, et cetera. This is really important. The oceans-based, land-based, and ocean-based that Sarah talked about, if you look at, so I was in the Biden transition team, and at that time, I was asked to plan out what should be ARPA-C, the climate part. So I called up NASA at that time. David Crisp was the program manager for the satellite imagery for CO2 measurements. And his point was that we have 2 satellites at that time that were beyond the life expectancy, and there are no plans to, replace them. And they were measuring 1% of the Earth's surface per month. And with that, they were detecting that the Amazonian forests and the African forests, the tropical forests, which in all climate models are assumed to be the lungs of the Earth that take in, were slowly becoming sources of CO2. So, to measurement, it really changes the ball game in terms of modeling, et cetera. So I would say that is absolutely critical. We should have a constellation of satellites plus land and water-based, ocean-based measurements. I think that data should be public. Everyone should be able to use it and not privatized. I think because this is really for the public good. On the issue of accounting, which I think is a super important thing as well, we don't have really international carbon standards. And if we had that, there would be a lot more use of carbon voluntary trading that is going on. Everything today is voluntary. There is no carbon tax, for example, in the United States. But people are willing to do. I mean, Microsoft or someone may want to, have some carbon credits. But we don't have any carbon standards. So there are billions of dollars waiting to be invested, as long as there's a trusted standards. And I think this is, again, a public good issue where the government, like an SEC or some other government organization or nonprofit organizations, can come up with standards. And this goes back to some of the things that you was talking about. There's scope 1 and scope 2 is relatively easy. The scope 3 is difficult. And we need a whole supply chain understanding of that. And there are new approaches. There's one that just got the McKinsey and other award from Harvard and Oxford called e-liability. That really, just like you have you buy a food and there are calories out there with proteins, carbohydrates, you could do the same thing for carbon, water use, et cetera, and use cost accounting principles to be able to do that. Once you have those kinds of things, then the whole supply chain can be worked out. But those are absolutely necessary. I would say these are early days of that.
I mean, I want to maybe comment on a question you had at the end of the morning session. I personally think that we have a need for a global planner. So many things need to line up for us to slow down global warming, right? I mean, everything we're discussing is a piece of that. But without a global effort to strategize and act on a plan as opposed to just having commitments is probably required to be successful in the future.
Ready for you. Yeah.
I'd like to go back to your question,
Yeah.
Deanna. So I'm a consumer of a product, and I get some rating indicating its sustainability. How do I judge the quality of that? And again, just using the example of the energy systems and the natural gas, how do you take data that you're getting from North America, where you have measurements made at multiple scales and hundreds of thousands of overflights of sites and so on, to Russia, where maybe we'll get some of the global satellites that give us public information, and we can use that to label its product. But how do I develop an indication of what that data quality is? I may be able to generate a number, but how do I get an indication of what that data quality is? And that's a challenging problem, perhaps an academy study to do that sort of activity, to give guidance on what does that look like globally. Here's your number, but here's also an indication of how good those data are and the underlying analyses associated with it. Global standards and then reporting in a simple way that results in a composite index.
We're hearing a lot about global standards here. So, and Sarah, I'd love to hear your thoughts on this.
Yeah, to build on Arun also, our job is monitoring the Earth and doing so operationally. And so I agree with that on you can use a constellation of satellites for specific information, but there are limits to different technologies. And so there's actually a patchwork of different types of technologies that we need, where we need the satellite piece, but actually to go to those really local scale oil and gas wells, we worked with NIST and developed new technology, and now there's several companies off of it that actually use lasers to be able to monitor really, really quickly. And it's because the cost of that technology is so low versus the cost of leaks. That's actually being deployed on oil and gas sites. And so that adds another layer of information that there might be much more confidence in certain types of reporting than other types of reporting, that then you layer on these different reporting to be able to really have confidence in one versus the other. And then we also, the satellites can go to the top, but then you have these local measures that you need, and then really importantly in the ocean, and the ocean is actually the largest carbon sink of the world, we also need sensor technology, these autonomous drones, the measurements that we're taking across the ocean, deep into the ocean, because satellites don't penetrate in. And so that's what we have with the Argo system and various other buoys and information, where we actually have these gliders going through the ocean. They dive deep and then they come back up and they give us temperature, salinity. We even have biogeochemical ones. So we need all of this to know what's happening around the Earth at any point in time, and then that all gets recombined into our expectations for the near future of weeks, months, into the more distant future of years to decades. And all of this gives us that scientific information that we need. But then on your comment on simplicity, I want to comment that we also are going to realize that it's not always going to be reducible to one number. And that is going to be the real communication challenge and the comfort challenge for people to understand the nuance and the complexity of these sustainability challenges, especially as we move into how do we adapt, how do we build resilience, because the key performance indicators for those are so diverse. And comparing one ranking of one versus another is apples and oranges. And so you can't necessarily do that. And so there will need to be nuance and understanding. And that's what makes some of this so hard, is the communication around what those key performance indicators mean and how to understand them is going to take some time.
Okay, we're going to start right here with our first question.
Thank you. Dave Dzonbak, Carnegie Mellon University, and I'd like to thank all the panelists. I'm going to take us to the part of sustainability related to the social dimension. So we've had discussions here about system-level analysis, quantitative analysis, data collection to support that, and policy formulation from that. And it's unavoidable, but it strikes me as a bit of top-down and communication. We're going to communicate our good ideas. And it's just a matter of communicating those well enough so everybody gets our good ideas. But communities have their own ideas. And we in civil and environmental engineering on the front lines of that kind of stakeholder engagement. So my question is, to any of the panelists, how can we move to more sophisticated approaches for stakeholder engagement? Finding out what communities want. I was telling some folks I had the occasion this summer to drive around New York State and Massachusetts that have incentives for solar development. I saw a lot of impressive utility scale PV solar, but I also saw a lot of signs pushing back on that. No more solar farms. So the social dimension, we need advancement in that as well. I would posit it's not just a matter of communicating our good ideas downward. Welcome your comments.
Great, and I think that question is really at the root of listening to our communities. I think you could argue listening to corporations and their needs. So I guess why don't we start here, Sarah?
Yeah. So at NOAA, we have offices in every single state. We have regional CAP centers that are bringing climate information into the regions to be able to work with regional communities on being able to do that development of how do you take the information in the community. In my remarks, I mainly talked about the top-down approach, but we very much have community engagement across the entire nation, all of our territories, on how to use that climate information to be able to build up those plans. And from those they're called CAPRISAs, what we've learned from a lot of those too is that when you are dealing with an issue, particularly in underserved communities, there may be multiple issues at stake. And so if you don't design the solution that handles an understanding of those different issues, you will develop a solution that will not have longevity. And we've also seen this a lot in the conservation space, that if you develop one idea for one thing, you spend some money on it, and it's too complex or the people can't use it or the people don't support it, then you won't have that conservation effort. It will just die as soon as the money goes in. So there's a really important part of developing solutions within that community engagement. So we have the CAPRISA program, all the offices in every state with our weather forecast office, and then also, particularly for coastal resilience, which is an increasing concern, we have something called Sea Grant. So many people have heard about land grant universities, but they don't realize there's actually a coastal equivalent through Sea Grant. And so that works, and it brings federal information and dollars in together with state and local groups and the academic institutions, but also local businesses around different types of issues in the Great Lakes as well as the salty coastal communities. And so those efforts may be something like we need to build out coastal resilience for this area. So it might be a wetland restoration, it might be hardening of it. But all of that takes into account the community engagement and needs, and then it brings also the funding from across all these different funding streams to be able to do that with the goal of that community resilience long term.
Yes, Arun.
So first of all, I couldn't agree more. I think the COVID example is a really great example that it's one thing to develop vaccines, is an entirely different thing to get people vaccinated. And so I think there's similar things out here, the social aspect. I think trust things move at the speed of trust, and building trust with communities, not just helicopter in and going out, but over time, trust takes time, is going to be very, very important in this. I think trusted institutions would be extremely important, whether it is religious institutions or other institutions. And so we have, and I'll say a little bit about Stanford, we are launching a new institute on sustainable societies, where this institutional organization, having partnership with institutions that have built trust with communities is going to be important. So this is one of the efforts. I would also say that this is an international issue, not just a domestic one. And there are marginalized communities out here, and there are marginalized communities elsewhere. Having engagement domestically with marginalized communities, because they'll be affected most by all of this. Having that trusted relationships, building that now within the United States, but internationally, I think is fundamental, because if we don't have them bought into this transition that we're talking about, it may not actually happen. So getting the people on board is going to be absolutely important. So you're right on.
Great. I think we'll go to our next question over here.
Thanks. I'm glad I get to ask the question this time around. So I want to ask around the question of mobility, because I don't think we got enough attention to this. I'm Christine Economides, by the way, from the University of Houston, and I have had the pleasure of working with a couple people on the panel in the past. So back to this mobility story. I've spent my career working in the oil and gas industry, and we have enabled significant greenhouse gas emission reduction through supplying natural gas for electricity. But natural gas can also supply hydrogen. And I've talked with GM, and when they say they're going to do only EVs in the future, they don't rule out hydrogen fuel cell EVs. And I think mobility is freedom. Maybe we're not all going to spend the rest of our lives on computers in virtual meetings.
Or maybe we will.
Or maybe we will. And so I really am not sure that we're seeing enough emphasis on how we could leverage the infrastructure that oil and gas industry has built over the more than 100 years now towards a switch towards, as well, hydrogen. I think the battery EVs belong in the picture, but I think hydrogen as well. And I mean, David is all over the worries about the methane emissions if we take it from methane.
So I think there's a couple questions in there. We have a focus on hydrogen and its role in these sustainable solutions. And I think if anyone also wants to take on this issue of mobility, and I think that also just speaks to the greater thing of whether we're willing to give up things for sustainable choices as well. But let's start with hydrogen. Does anyone want to tackle hydrogen and its role in the portfolio of sustainable solutions? I know, Arun, you mentioned that a little bit earlier, but Dave, do you want to take that on?
Well, I think that the question Christine raises is broadly about molecular fuels. Can we use some of the infrastructure that we've developed for molecular fuels like oil, like gas, for molecular fuels like hydrogen or ammonia or any of a number of other types of molecular fuels that have been proposed. And those will pose some of the same challenges that we have right now with our existing systems, about worrying about these complex infrastructures. How do you ensure their sustainability? How do you really measure that, report it, verify it? I think we'll learn a lot from those things, and we can build off of them for for molecular fuels like hydrogen, ammonia, others. So many parallels, and also the possibility of building off of existing infrastructures.
Thanks very much. I just think the National Lab tools enable us to see the affordability of hydrogen as a fuel for consumers at a cost they can support. And it takes us away from so much expense on offsets for combustion emissions. Thanks very much for the opportunity.
Thank you for your thoughts. Yes, and we're going to go here for a new question.
Hi. Nathan Meehan, Texas A&M. This is maybe for Dean Majumdar, but
It may be for who?
this may be for the dean, but
The
anybody
dean.
else?
All right, he's now the dean.
So, well, you are the dean, right?
Yes.
So, the oil industry, following up Christine a little bit, produces 100 million barrels a day of crude oil and is rightfully proud of the contributions to quality of life that they've made over the decades. But every forecast that gets us anywhere close to 2 degrees has oil production dropping at least by half and coal production nearly disappearing. The planet doesn't have much of a track record of ever using less of any kind of energy. I mean, we burn more sticks. I think we burn more manure now than we ever have. And some of us are just incredibly skeptical that people will give up any quality of life, much less substantial amounts, and that we will successfully move away from oil and gas in the kind of timeframes that would be required to reach those. I just like your thoughts and comments about, the credibility of it. I see the forecast, but I'm not sure that I quite believe them yet.
That's a great question. There's a saying, I think it was by the oil minister in Saudi Arabia, who said that the Stone Age didn't come to an end because of the lack of stones. And because they had better solutions. To your point, we will be using oil and gas and coal for the next 2 decades. I mean, that's just the reality of where things are around the world, whether we like it or not. We cannot impose the solutions of the United States on Indonesia. We have to meet them where they are. Every country and region has their initial conditions and the boundary condition, which are different. And so just the practical reality that we will be using fossil fuel. The question is, what do we do to address the climate change, which is also urgent? So negative emissions technology, trying to replace, I think in the better solution, or at least an alternative solution right now, is electrification of light-duty vehicles, right? There are energy used for making batteries, et cetera, but at least it reduces air pollution, and that's a vector that matters to a lot of different parts of the world. And when the grid gets decarbonized, that's a way to reduce emissions. And if I talk to the oil and gas companies that I talk to, they say that the peak demand in oil will be this decade, or maybe in the transition from this to the next decade. That's what I'm hearing. And so I think the reality is that we will be using fossil fuels. The question is, can we manage the carbon? That's really the issue. And the transition will not happen overnight. I mean, just the scale of this issue is so big. And it will take at least 2 or 3 decades to do that.
Yeah, go ahead, Sarah.
I also want to add the assumption of loss of quality of life due to a shift in energy systems. There's also a loss of quality of life with ongoing climate change. We're really concerned about food security going forward. I held a press conference a couple months ago now with the State Department spec for food security, where there's concerns about food security with a growing El Nino. We also have what we just saw in New York City with the flash flooding in places, record flooding that has never happened before in the infrastructure. We had a summer where large portions of the United States had wildfire smoke coming down from Canada, where then people couldn't go outside. These types of events, like this summer is going to be cool by comparison in the next 10 to 20 years. The events that we're experiencing now are going to be lower in number by what we will continue to experience. And so there will be a shift in our quality of life due to climate change as well. And so it will be a matter of the investability in both the energy transition and the investability in adaptation and resilience. And both are going to start happening at a more rapid pace, I think, as people respond to the events that they experience and that they see. And in my work traveling around the United States, but also being involved in the UN and the work on climate there, people are responding and are emotionally desire to do something is at a peak that I've never seen before.
People feel the impacts of all of these impacts. People feel the impacts of the effects of climate change every day. But I think it's interesting because from a communications perspective, it's like, okay, maybe we can change this narrative from you have to give up something for a sustainable future versus, no, you need to do this and it'll create a better future. And flipping that switch in terms of, as a consumer, not having to give things up, I think is a positive shift. Another question over here, yes.
Sure. Frank Zane, School of Medicine, University of California, Irvine. So my question is about bottom up. The population, the growing population is responsible for the challenges we're facing now. And part of it is not only we live longer. 50 years ago, the life expectancy was 50 years old, and it may double in the next 50 years. Right? And we have a lot of more aging population. Right? And also, I think the lifestyle change is also critical, right, to sustain. And I wonder the panelists' thoughts or comments on how do we mobilize the individuals so they are responsible, produce less carbon footprints, and that be maybe more cost effective, right, than perhaps the policy, which is critically important.
Yeah. Okay, so I think this question, it's yet again focused on the individual. I know we talked about some of these lifestyle changes, but I think this also harkens to some of these global plans and things like that. So Erkan, why don't you take this?
Yeah, maybe I can take that on. I think this is a good example of creative destruction. Like a lot of things need to happen, and I don't think general public really understands what they need to do and the consequences of the destruction that's coming. Right? I mean, there will be a lot of people who will need to change industries and jobs. Right? If we're going to use 50% of the oil that we're using today, they need to know that now. And I think that needs to be in our messaging. Or the changes in U.S. economy, right? I think the U.S. will have to do much more than other countries to make this 2-degree warming scenario, and that will be a major shift. Like we don't have it's all about trade-offs, right? We don't have unlimited amount of funding to continually support healthcare system, education system, climate change at the same time. So I think it's really critical for the general public to have that message.
Anyone else want to take that? Yes?
So one of the things that there are a couple of reports that have come out, one from Economist, the other for IBM, where they show just Google search on sustainable products is going up exponentially, not just in the United States, not just in the West, it's worldwide. Now that's a good news that people are looking for sustainable. The problem is what you were saying, it's very hard to say what is sustainable, what is not, because of what the metrics are. So if you fix the metrics so that there's no greenwashing, because a lot of greenwashing happens in sustainable products. Mm-hmm. But I think that's an indication, at least in the Gen Z and the millennials, maybe not people my age, but Gen Z, this is a real issue. The other thing I would say, and since you mentioned international global, I just spent 3.5 weeks traveling in 5 countries in Asia. You don't have to tell people that there's climate change. It's in their face. And I think there'll be unfortunately, there'll be events that'll be happening where people are at some point going to say, we got to do something about it. And I think that acceptance of, hey, there's a collective measure of what you could do collectively, like infrastructure, policy, that's a collective. And then the question is, what do you do personally? And we need to get ready for, for simple things people can do, trusted institutions that can pass the message that, hey, this is what you got to do. But you got to do it at scale. If I take, I take cold showers. I don't take hot showers anymore. Okay, that's my personal thing. It ain't making a change on climate change, but it's just my personal habit. That's not going to change things unless you get it at scale. Right. And the scaling is how we get that, leveraging information technology infrastructure that is already there. Everyone's going to have a phone at some point. We already have. So using that mechanism to get to people is the demand side issue, which really has not been cracked open yet. And that's an opportunity.
Thank you.
And I was also thinking, there's a behavioral economics aspect of this. Average person heavily discounts future outcomes, right? In 2050, it will be warmer. Most people don't care, right? I mean, they did this with tobacco products, right? They said, okay, you're going to have cancer in 20 years if you smoke. Hey, I discount it. I don't really care. But then they changed the messaging to, you have terrible breath, right? That's affecting your life today. So in a sense, I like seeing these flooding events. I like seeing, some of the, because now it's an easy message, right? I don't have to explain to a general public or a company that, hey, you need to think about this risk. It's happening today.
That's great. Thank you.
Yeah, go ahead, Sarah.
Related to that, as the millennial on the panel, there's also a bunch of research on students coming out of business school right now that over half, over 2/3, only want to work at companies or for places with cause around sustainability, around the environment, around social issues. And so it's also creating a premium on the workforce of the new workforce. If people want to work with places that have these missions and are going to build the solutions for tomorrow. And additionally to that, if we play this out, if we say that people are going to really care about things, that we're seeing the investments from IRA, BIL, we're seeing investments in universities creating whole schools for sustainability and climate, the future of innovation and the future of these industries is going to require that innovation in those technologies. And so we're also coming up to a point where the countries, the places that create those key conditions to be able to build that innovation, those will be the places where economies and commerce will thrive if we can do this right. And so that's part of the reason there's this whole government approach right now around dealing with climate, because it's a systematic issue, but it also creates incredible opportunity, if done well, to be able to spur that type of innovation. And since I'm in a room full of engineers, I also wanted to make a mention that for climate mitigation technologies, our sister agency, U.S. Patent and Trademark Office, has a fast track for patents that do have climate mitigation for reduction or removal, avoidance of greenhouse gas emissions. It takes 12 months for a patent. And so that's one of the key pieces. We need to spur this innovation as fast as possible right now.
And I think I'm just going to follow on to that. It brings up the question of voluntary changes or voluntary reporting versus regulation versus policy versus requirement. And I know, Erkan, you spoke to that earlier. I mean, right now it's voluntary for companies to be reporting on this, but there are regulations coming. I guess, do any of you want to talk to that balance of how much we need to really push towards regulation versus how much it's more communications and, sort of meeting people with oh wow, there's a lot of issues going on with climate right now. I voluntarily want to change this. Where's that balance? And how do we deal with that balance on a global scale? I'm just going to throw that out there.
Well, it's not an either or.
Right.
They're both absolutely necessary. A number of the questions that have come in have been related to how do you get community engagement and support and aim these sustainability measures and actions at what the communities really want. And so it's got to be both communications and building support within communities, as well as then thinking about regulations and structures that enable change to happen.
Yeah, I mean, I agree. I think it's just asking companies to report on their contributions to climate change is just another piece of the puzzle that we need to resolve so we have better access to data. I mean, we're collecting a lot of data, we're building a lot of reporting systems from environment, and then this is just, in a sense, like, speeding up the process so we get access to data from the companies.
You know what the business world needs is a long-term predictable signal that they can optimize on. The most dangerous thing that we could do is that the signal, whatever the policy is, changes over time. It's very hard to then optimize and provide asset allocation in a company when you don't know what the policy is going to be a few years from now. So I think this is where governance, this is where leadership from Washington and other places come in, where they actually have a predictable. It could be a price on carbon. Now that seems a little difficult right now, but there's some other regulatory signals that are there. Make it predictable over time. And I think then the business community will respond to it. Now there are some things that, and as I said, the Inflation Reduction Act today is terrific. It's a first down payment, but it is only incentives. And if you really want to move fast, that we have seen in solar and wind, you need investment and production tax credit, that are the carrots, and you need a renewable portfolio standard, that's a stick. You combine those, and then it becomes predictable, and you can go fast, it's bankable. And I think that's what you really need right now. Someone asked about what is the plan? Well, if those kinds of combination of policies are needed for a country to move, the whole economy to move. Right now, you'll only see a few things kind of bringing the green premium down by scaling with incentives, but that's not good enough.
Okay, question over here.
Hi, Andy Jackson, University of Pennsylvania. Thank you very much for your presentations, particularly yours this morning, Arun, where you brought all those things together in one 40-minute presentation, which I thought was very valuable. Unfortunately, the last thing you talked about was essentially my question, but I'm going to ask it anyway. You mentioned that we have a lot of carrots, but we don't have many sticks, and the carbon tax is the stick. But it varies all over the place. The social cost of carbon, recently the Biden administration came up with $180 and API counted by 20. How do we come up, using all the data that's available, with a credible, acceptable social cost of carbon that could then be translated into the sticks that you were just talking about a minute ago?
That's specifically for you.
Okay.
Dean.
Well, so look, if you ask an economist, and you can correct me if I'm wrong, the most efficient way to approach this is to put a price on carbon tax, or carbon dividends. George Shultz and Jim Baker, they had collectively come up with the revenue neutral carbon tax. So you put a carbon tax, adequate tax, take the money and give it back to people through, payroll offsets or just the Social Security payments. Now, that's a revenue because it's not a drag not a fiscal drag on the economy, because you're putting the money back, as opposed to putting it in healthcare or something else, right? So that was the idea, and 20-something Nobel economists signed up to it, the multiple Wall Street Journals. And if you ask the question, what has happened? Nothing. And because the political economy is such that it's not going to go through. So you need other measures of doing so. And one of the first things that got dropped out of the Inflation Reduction Act, which is a misnomer, first of all. But the first thing that dropped out was a clean energy standard that was there in the plans during the transition, the clean energy and efficiency standard. That was the first thing that dropped. I think we need to go back, because we got to keep at it. We cannot be sitting on the sidelines and saying that the carrots are going to be enough. We need to go back, and whether it's a carbon tax or not. The other combination is how the electricity system, if you go back in history, the electricity system in the United States got developed with federal incentives and state combination, right? So here is an opportunity. If any state wants to receive federal dollars, and there's a lot of money out there right now, if the state could develop regulatory policies or some measures that where the sticks are in the states and the carrots on the federal government, that's a good state federal partnership that could really move the needle. And that is what is going on right now.
So that solves the problem in the United States, perhaps, but how about on a global level? How do we handle this, get a credible value for the global community?
Well, globally, almost a third of emissions are actually covered under a carbon tax or on cap and trade. So we're talking about what's happening in the United States, but other economies are using that to be able to figure out how they can efficiently allocate capital towards mitigation.
But they do seem to be different across different countries. How do we rationalize it so that the world can say this is what it's costing us as a globe? It's a global problem. How do we rationalize it as a global issue?
I mean, there is a border adjustment carbon tax idea out there.
Yep.
I'm not sure it's a really good idea because, again, you're putting a tax without acknowledging the fact that different countries are starting from a different initial and a boundary condition. And so you're not giving enough room for certain countries to grow and you're penalizing them. And I think internationally, first of all, let me just back up and say, climate change is going to be a major geopolitical issue because of trade, because of the emissions from one country. Most of the emissions have come from the United States. If you look at the cumulative emissions of CO2, and the impact is somewhere else. So they need some financial transactions to happen and the global north to support financially the global south. What are the mechanisms to do that? We don't know yet at the $1 trillion level. That's still up in the air. And those carbon standards, the trusted standards and all are absolutely needed to manage this geopolitical, potentially really volatile issue.
And to add to that, like the basis of some of those issues too are very much related to food security, water security, what is going to happen on damages to the built environment and livability in all those places. And so in every country, depending on where they are in the world and the experience of climate change that they will have, it will lead to different responses of what they're doing within their own society, but also the available solutions that are available to them.
Thank you. Thank you.
Over here for the next question.
Yeah, Jim Harris from Stanford University. I think Arun went to George Schultz's school on economy, and I heard George talk 4 or 5 times, going back probably 25 years ago, where he was a very strong advocate of a carbon tax, which I fully think is one of the best ways to go, because then you give companies, you know what you do is escalate it. So they know that over time, I've got to fix this problem, but they can do it within their constraints and choose what routes they want to take. But I think we need to have standards and set, as Arun was saying. And at that time, I've done a lot of work on semiconductor sensors and lasers, and at that time, it really wasn't, you could do permanent kind of things, but now their lasers and everything are so small, you can fly drones, and the characterization of who's violating is easily discernible. So I think that's one thing. The other is probably for 30 years, I was opposed to any nuclear energy. At that time, from 1970 to 2000, it was a safety issue to me, but I think they've solved all those problems. The question is, what do you do? And I think there's a lot of fear resulting from, Fukushima and things, and a lot of the EU de-escalating their use of nuclear power. I think much as I hate to say this, I think we just absolutely have to have that. And the question is what to do with the nuclear waste. So let me pose a totally crazy question. I think the only way is to buy people off. So if you offered the people in Nevada 25 years of zero federal income tax by putting a storage facility in Nevada, I bet you they would go for it. And there's the best place on the planet to store it. But I don't think, everybody says, not in my backyard. I don't think it'll ever happen unless you buy people off in some way. Okay.
How's that for a carrot?
It's what?
I said, how's that for an incentive? Yeah. Okay, so I think let's summarize the role of nuclear energy and sustainability. We're going to go with that one.
Yeah.
David, why don't you start with that?
Well, no matter what our source of energy is going to be, we still need to think about the grid and delivering it to where it's going to be needed. If this part of the solution for decarbonization broadly is more and more use of electricity in transportation and industrial processes and on, then yes, we need sources, but we're also going to need to face the problem of the grid. So it's a piece of a puzzle, but a big missing piece is going to be how do we develop the grid?
Got it.
I could just
Yes, go ahead, Arun.
I completely agree. We have to have nuclear. There are some real experts out here on this issue. Look, I think we have not built nuclear reactors in the United States for a long time. And we got to restart that. Small modular nuclear reactors happening. Canada is installing a GE reactor, small modular. I think that's going to, that'll, if you can bring the cost down, and the first one that you do is always more expensive, so someone needs to take the risk. This is where some DOE loan guarantees, which has happened in the past for nuclear, but for the small modular nuclear, if you can reduce the risk of, and then bring in private capital through that is going to be super important, and getting the market going for adoption of nuclear. Because it's not just the United States. Having traveled now around the world, everyone's looking for nuclear solutions, right? The waste problem is a thorny political issue. How the Nuclear Waste Policy Act got amended and how Nevada became, look, my first office in the Department of Energy was in the Yucca Mountain office. So I know what this is about. And there are some serious, issues politically on this one. And there has been a Blue Ribbon Commission that was put together when Stephen Chu was the Secretary of Energy. There's a report, and someone needs to take that on Congress and actually follow it. So it's a political policy issue that needs to be addressed. The technology is doable, of course. We do it for the waste from the military, from the nuclear navy. That waste is managed. The civilian one is what we need to figure out. So there's a lot to be done, but it's not all technical. There are policy issues that need to be fixed in Congress.
Great. And I want to bring up, I know earlier when you were speaking, Arun, you showed kind of a grid with the school of sustainability and how it's so cross-cutting. You have to think vertically, you have to think horizontally. I'm also hearing this is one of the many puzzle pieces. There's so many different puzzle pieces. I'm just going to ask a very armchair question. Can you give us like 101 on a national level? Like, who is overseeing all of these different puzzle pieces? Who is, what groups are we leaning on? Obviously, besides the academy, what groups are we leaning on a national level to come up with this plan or to oversee all of these different verticals, horizontal, all of these different groups? Can you guys just give us a 101 on that? Yeah.
Well, under this administration, there's the Climate Policy Office within the White House that, on domestic policy standpoint, is overseeing all the policies. Originally, was very much focused on mitigation. Now, as of last week, with the new resilience framework, also in adaptation resilience, and it's looking across all the different agencies and all the projects and all the policies coming out. You also have, from the Science and Technology and Innovation standpoint, the OSTP, the Office of Science, Technology, and Policy, also in the White House, working closely with them on what is the future of science and technology, underpinning all the things that need to happen, and then doing coordination across all the federal agencies to be able to produce that.
Great. Awesome.
I mean, look, there is no Department of Climate or Department of Sustainability in the federal level. In fact, President Biden, when he was candidate Biden, had proposed ARPA-C, and I found myself trying to figure out what ARPA-C is during the transition time. And there was a proposal that went to Congress, and well, it didn't quite go to Congress as a bill, but it went to Congress as a proposal from the White House. It didn't go anywhere. So I think we have a reality. We can't wait for that agency to come around. We have a reality of what is already existing now, where NOAA, USGS, Department of Energy, NSF, everyone has equity in this. The question is coordination. The White House is the coordinator, has to be the coordinator in this. The problem with the White House model is that they don't have any budget. The budget belongs to the agencies. So how do you get the White House to coordinate in such a way that all the agencies are working in sync with all the budget authorities that they have, giving authority without the budget, frankly, it's weakening. So I think that is what would be really important, and the White House leadership is absolutely critical. Whether it's a climate team, whether it's Ali Zaidi or the other folks, that is going to be super important in this.
Thanks. Question here.
Yeah, my name is Fran Oseo Asari. This has been a very fruitful weekend. A lot of things have been discussed, and it's been very helpful. However, I just want to make one small observation. That is that every time I have a snack box, a bottle of something, or a plastic bottle of water, and I go to dispose of it, there are no recycling bins here. There are no for cans, for paper, and I don't understand why, because you're modeling for the country good private lower level behaviors, and so I would appeal to the National Academy to allow us. I mean, I know there are cost issues and health issues. You know, you actually have actual cups instead of paper cups for coffee, and I appreciate that. But I wish I didn't have to be adding to landfills. Thank you.
I think it's a good point that it goes back to mandatory, voluntary, and
well, the National Academy can make decisions, can't it, on its policies on a local level?
Yeah. Okay. I think.
I actually asked yesterday, and there are actually a place to recycle the National Academy, but you have to go through stairs up and pick.
All right.
Bring them
Okay.
downstairs.
But it sounds like that's less of a question, but more of an action and a follow-up. And I should say, the point of this is not just to have this conversation now, but to continue this conversation. So I think that's a really great point, and I encourage you to continue the conversation, whether it's recycling on a floor above or what you can do in your respective work environments to keep pushing this forward. Yes, question over here.
Yeah, hi, Dan Hart, consultant. You know, it seems like we're heading into an existential crisis, and we're taking a light management approach. You know, which is an interesting strategy. We recently had an existential crisis where we took a messy but a pretty hands-on approach, and of course that was COVID. You know, and there's some assumptions being discussed that, I mean, the demand slides that you showed earlier are amazing. I mean, absolutely amazing when you look at that super exponential climb. So clearly demand has got to be hit. And we recently learned that behavior can be adjusted, albeit with difficulty, right? I mean, we just walked down Constitution Avenue. All of those office buildings maybe don't even need to be there. You know, we don't need to travel as much as we do. You know, and there's a lot of discussion you can have about effectiveness in business and person to person. And I'd be the last one to say I want to do a video call, but we can do it. So we can change our behavior, and we do have individual metrics that are not related currently to climate. I mean, you know, you pay more insurance on your car if you drive longer. You're going to pay, you know, electric bills, but they're not amplified because of this issue. They're usually due to other considerations. So, getting back to the gentleman's point on individual accountability, you know, I mean, what gets measured gets fixed only if there's a strong feedback loop, your carrot and stick. So if you were to pick 4 metrics that everybody in the United States should have and be measured on, what would they be, and what policy would you put in place to force us to do it?
Well, that's a lot. Maybe we can take that to 1 metric. I guess I'd even say, can you
3.
impose a metric on consumer activity, right? Yes, Erkan.
I mean, I don't have any of those answers, but I'll start. So for example, what companies started doing is understanding your carbon footprint. Like when I'm trying to decide to fly, travel, purchase anything, I get an estimate of the carbon impact of my decision. So, and then my business line is priced internally. So companies started having these policies, internal carbon pricing, and they're charging my organization based on those estimates. So there is an incentive for me to minimize it. It's in one of my metrics as an employee, but not as an individual. But maybe David can comment on the work he's involved in, where consumers need to understand when I'm buying a bottle of Coke or a piece of product, I want to know my impact, right, through the product. And we don't have that information yet as consumers.
If I were to pick two metrics, one that I would pick would just be energy use. So every activity that we do, from the lights that are on in this room right now to our transportation choice, getting to and from this building, having individual level knowledge about what our energy consumption would be. Like Arun, I teach freshmen about sustainability every fall. And you ask a college freshman about the amount of energy that they use, and they have no idea. Right? A second would just then be materials that we use. How much material do we use every day? One interesting experiment that I have seen implemented at a university, not my own, is during Earth Week to have students carry along a trash bag with them for the week and put every material that they would otherwise have thrown away into that bag and carry it around like Dickens' Scrooge, carried around with them for the entire week. And that's a really compelling message. The per capita materials use in developed countries is about your body weight per day, if you account for all of the materials used, not what you throw in the trash, but your overall materials used. So just getting metrics like that about those tsunamis would be just incredibly powerful.
And they sound like the analogs, individual analogs of what companies are doing, right? With, you know, my waste management, my motor management, my emissions. So maybe they can be individualized.
Yeah, I would add to that water is the other metric. Yeah. And I don't think people realize how water is not necessarily a renewable resource, and we're using water, especially groundwater, as insurance for when we don't have water on land surface. And so in the United States and around the world, the groundwater is running out because it takes years to millennia to be able to replenish it. And so water would be my other one, because I think that that's a growing crisis that I don't think people are fully aware of yet.
Can I just offer a comment? You know, since I invoked Mahatma Gandhi's, today is his birthday, 154th, he had a very famous quote that you got to be the change you want to see in the world. And I think that's what you're asking. What change would you do? We offer it in our freshman class. Cam Moeller, my colleague, and I teach this class, co-teach this class. And the first question we ask is, if you were to reduce your carbon footprint to the global average, what would you do? Right? And you immediately realize food is a major emission. So if you cut down 1 day a week of meat, just go vegetarian for 1 day a week, and if everyone did that, that's a huge impact, right? So that's one you could do. You could, energy use in buildings, textiles, and all of that. But at some point you realize that you depend on infrastructure where individual decisions may not play a big role, because you're getting your electricity somewhere, you have a car already that you have to drive, and so there's a collective action as well. It's not just individual. Individuals, you can only go so far. By the way, United States average carbon footprint is almost 3 times that of the global average, right? 3 times. So you cannot just go down factor of 3. And so that's one realization that you have. The second thing is flight is a huge, the fact that we are flying out here has a big emission footprint. And so you ask the question, what can you do to reduce the fuel? Can you introduce carbon neutral fuel into the biofuel? So the International Civil Aviation Organization, which is part of the United Nations, has a goal, a target of 10% blended biofuels into the fuel. That is not ambition, because if you really do 10%, that's an additional cost. It's about 3 times that of jet fuel. If you pass it down to the consumer from a Tokyo to London flight per seat, that's only an additional of $20 or $30. There's a study on that. Now, is our corporations like a Microsoft be willing to pay, if their executives are traveling, extra $20? I think that should be part of the plan. So, going back to your question, this may be something that the national academies could look at. What are the things that you could do individually that could reduce the carbon footprint? Because I think that information doesn't quite exist in an easy way. And if it goes into the engineering curriculum or other, maybe the next generation could do it. But this should be available to everyone.
All right, question over here.
Yeah,
Thank you for your
my
question.
name's Peter Cummings. I'm currently at Heriot-Watt University in Edinburgh, Scotland, after spending 41 years in academia in the United States. I just wanted to say something that reinforced what Christine said earlier about hydrogen. I think hydrogen is making big inroads and it's not very detectable, because I think what people immediately think about is hydrogen-powered cars, and what you want to do is forget about hydrogen-powered cars. You want to decarbonize heavy transport with hydrogen. You want to decarbonize shipping with green ammonia, that sort of thing. Not be thinking about individual vehicles at this point. Last week, the UK, and so Scotland is a huge producer of wind power, much more than it can consume. And so it's now at the point of wanting to export hydrogen based on producing hydrogen from wind power using electrolyzing water. And there's huge potential for that in Scotland. And last week, the UK and Germany signed an agreement that would lead to building a pipeline for hydrogen from Scotland to Hamburg that would supply green hydrogen to Germany. And I think these kinds of things don't get the visibility that maybe they might get in other contexts. I just think that I'm just reinforcing, I think, what Christine said.
Yeah, and what's your, and specifically within hydrogen, what question do you have?
No, I think the perspective, I guess I'm trying to point out the perspective is very different when you're in other countries. I mean, this has already been mentioned, but I'm learning to have a very different perspective based on where I'm living now.
Great. So another question about hydrogen, but I think that the big tone there was just other countries are also developing solutions. Obviously, the U.S. is a big player in this space. We've talked about a global plan. I'm just going to maybe spin that a little bit to be on the global stage. Is the U.S. leading? Are we following? I guess, are there things in terms of hydrogen in other areas of the world that we look to that we want to implement here? I don't know if anyone wants to take that. Arun or?
Well, I can take. It really depends on whether you're talking about technology and what kind of technology. The electrolyzer technology, there is a lot of work going on right now. It's been going on for a while, funded by the Department of Energy and National Science. There's a lot of that going on in terms of R&D. Alkaline electrolyzers are now coming down in cost, and so are solid oxide electrolyzers, et cetera. People are pivoting from solid oxide fuel cells to electrolyzers right now. There are major cost reductions going on in China. And I think we have to be, we have to watch that as to what's going on. So the cost curves of the electrolyzers, which used to be $1,000 a kilowatt of electrolyzer, that's coming down to about, $400, $500, or $600. It has to come down by a factor of 2 more. So that's the learning curve in developing the system that'll come down. So I think we are watching that. The United States is right up front out there. I don't think we are falling behind in that in terms of technology development. But, the question is not just about, green hydrogen. I don't like to use these labels, but the hydrogen from electricity versus hydrogen from, I think there was a question of natural gas. Most of the hydrogen today in the United States is from natural gas, 95% or so. And then the question is, what do you do with the carbon? We're not doing anything with the carbon footprint right now. And I think some measures of using methane to produce hydrogen capturing the CO2 or doing methane pyrolysis or some other kind. There's a $1.3 billion loan from the Department of Energy to a company called Monolith Materials that is doing methane pyrolysis. And they were doing it for carbon black initially. Now they're pivoting to hydrogen, and that's the DOE loan. That is infrastructure compatible because you get solid carbon, which is much easier to manage than CO2. So I think that the United States is way ahead of others because that's not just a startup company anymore. And so I think in many ways, technology-wise, I don't think US has fallen behind or anything. I think we are right up there. The question is policy. And as I said, I go back to it, we have some major incentives for hydrogen, for green hydrogen, and there's a debate going on what is green and how green is green. That's going on right now. But nevertheless, $3 a kilogram subsidy or payment, right? That's fantastic, but there are other, like in UK and others, and Europe, there are other regulatory as well as incentive signals that are there for hydrogen. So I think you are going to see in the future moving forward, just like we have seen for photovoltaics and others, that there is as far as technology is concerned, the world is relatively flat. The battery that is made in China and the battery that is made out here is not that much different. The policy landscape, the world is not flat. And I think that's the inhomogeneity that you get. And by the way, Inflation Reduction Act, we may be quite proud of it. If you go to Europe and talk to other parts of the world, they're very unhappy about it because of the fact that it's attracting the industry over here, their industry, and B, there are some measures for protectionism, right? And so that has created all kinds of discussions and discourse around the world.
All right, next question here.
Yes, I'd like to address one other issue. If you look at the U.S. This time of the year versus in the spring and deep in the fall, the demand curve for energy, of course, is very seasonal here. The excess or the capacity we have has to be designed for the peak demand, obviously, of summer and winter in the U.S. Throughout the country, and especially in Texas, where I'm from. This is John Jenkins from Texas A&M. The issue just raised of generating hydrogen with the excess capacity that we have during the low demand parts of the season. That question is one, but there's a somewhat related question. Los Angeles is about to become infeasible in a single-digit number of years because of water, basically, the competition with agriculture in California between domestic consumption and agriculture. We don't have another Colorado River, so we have to do something on a single-digit number of years, I think, in the water competition. And, for example, desalination is a huge energy demand. So if we go to the ocean, as has been done in the Mideast and Israel, if we tried to go to a massive desalination in the U.S., that's a huge challenge. But responding to that challenge, in my opinion, is using our excess capacity either for generating hydrogen or doing desalination. And if we go back to nuclear, taking advantage of new nuclear technologies and designing those plants for cogeneration, either to generate hydrogen or to generate clean water through desalination. So I think this systems analysis approach needs to look at water and cogeneration going forward. And Arun, your points on policy are spot on. I think we don't have all the technology we need, but we have a lot that's not being utilized. And I think these are the observations I was wanting to make. And Arun, especially, I'd like to hear your response to that.
Well, I think your first question on the Texas grid, you live in Texas. Texas is unique. Because for those of you who are not familiar with Texas grid, it's an isolated grid, almost isolated, a few tie lines, and it doesn't come under FERC. ERCOT is on its own. And that has advantages in terms of regulatory oversight from the federal government, which they don't want. There's some disadvantages when things really go wrong. And I think, February 21, and more recently, I think this year, last year. But even otherwise, there's a risk associated with that. And what you're really pointing out is the demand-side management. Can you reduce load? Can you create what is called a virtual power plant? This is where information technology would be really needed in an aggregated way. And there are now, talking about the rest of the United States, FERC has created markets to be able to, or authorities to create markets to be able to sell demand-side services to the grid, especially when the generation is going down. And the most difficult part is not solar. The most difficult part is wind. And unfortunately, in Texas, there's a lot of wind out there. Solar, you know exactly when it rises, when the sun sets, and you don't put your solar panel typically in foggy San Francisco. You put it in the desert somewhere. But the wind is unpredictable, and we don't have the predictability of wind. So I think that's a great issue. The water issue, California, this is a difficult one, especially given the fact that there have been interstate agreements and laws that have been signed in the past that is at risk right now, given the demand of water, given Colorado River, et cetera. I'm not an expert in that, but I think one absolutely needs to look at the water issues, especially Southern California. Northern California, we have ice packs, and we had a massive rainy season this year, but aquifers still not full. We don't know exactly how to do that. And one of the things that's going on in the Door School, there are people who are looking at how to fill the aquifers in a rapid way. So I'll stop there.
Yeah, so in this move to renewables and in the water-constrained environment, there's an increased need for the types of science that give us both a forecast and the long-term understanding of variability and change. And so at NOAA, we are producing a lot of that information. Actually, our extension of our forecast and improvement in forecasts in wind and solar, or our weather forecasts out to 2 weeks, but also the extended forecast out to 4 months, we're finding that it's really important for the operation of those renewable companies, and we have some estimates that it saves costs of 10 to 20% when used effectively in operations, and we have case studies around the country where this has been done. We're increasingly being asked for that information to develop out more around the projection standpoint, out a couple of years to a decade, to be able to look at also variability, like particularly this summer, multiple heat domes in a row led to lows in wind production in parts of the United States. The wind wasn't blowing when we had those heat domes going through. And so people are realizing that they need more information on incorporating that into their analysis of both their operational capabilities, but their long-term work for building a resilient grid, which is why we're working so closely with EPRI and utilities now in a way that we never have before on the renewable side and building the grid side. On the water issue as well, and I can say this as an expert because my PhD and my work was on snowpack and water security in the American West. With that as well, there's now a push more towards being able to manage both the surface and the subsurface. There's only subsurface groundwater management in California and Arizona, and it's only in certain places. And there's a push towards the development of subseasonal seasonal prediction. So that's prediction of how much water falls from the sky, what the temperatures are on a month to a 2-year basis. And it's really coming from the stakeholders in the West. The Western State Water Council, which is made up of all the Western states, governor appoints someone. That group is really pushing us to develop more and advance the science of that. And we actually have the ability to understand atmospheric rivers, precipitation, temperature, out to about 9 months in advance. There's research now. And so now we're in the state of needing to transition all that research into operational products for its use. And with that as well, we're increasingly flying our aircraft into atmospheric rivers because we're finding that that allows us to know how much precipitable water is in them. And that's really critical for the water managers to know how much they should be releasing so they can make sure their reservoirs are growing in capacity as much as possible, because those reservoirs are both for water supply, but they're also for flood management in the West. And so that advanced information from days to weeks, but also to months, is really important for that water management. And so there's a lot of science that needs to be developed to be able to advance that, of the basic how much water is going to fall from the sky, what are the temperatures, how much is it going to evaporate. But then there's that co-development and combining it all together to be able to understand what should the management practices be. How do we, when we have a flood, how do we actually replenish the aquifers? Like last year, with California having so much water, the water was moved to farmland to be able to replenish the aquifers in a way that it can't when you don't have this excess water. So there needs to be management plans, both for times of drought, but also times of extreme water.
Thanks so much. It all goes back to the importance of how do you measure it and creating those tools, flying the planes into places. Yes.
And
David.
just a couple of quick thoughts and returning to a couple of themes from throughout the morning. One is everything's connected, and we need to look at systems and complex systems, and I'll use the example of Texas. So one of the largest water withdrawals in the United States is for thermal electricity generation. And so if you begin then to, as you're arguing and trying to cite grid transmission, why not begin to think about that as effective water pipelines as well? You can have, as we do in Texas, isolated droughts in one part of the state, serviced by ERCOT, and relatively plentiful water in other parts of the state. Why can't we displace that water use in the places getting drought with electrical transmission pipelines rather than aqueducts or water pipelines or using groundwater? So everything's connected.
Much so. Okay, question over here.
Mike Cavanaugh with Section 4. I'm a chemical and environmental engineer, and I have been involved with a lot of sustainability work on the National Academy studies, and I'm getting two major feelings from this presentation. First is the urgency of the need to accelerate the transition, and some optimism that the U.S. can meet the goal of net zero by 2050. I'm not so sure if we can get there without some kind of dystopian future, however, in terms of control. But I wanted to just bring us back to the sustainability, the definition of sustainable development, meeting the needs of current generations without compromising the ability of future generations to meet theirs. And without getting into discussion about how do we predict the future generations' needs, I'm wondering if the major goal of reducing poverty, which is one of the United Nations Sustainable Development Goals, is going to conflict with the desire to reduce carbon emissions. How are you going to get to net zero on the worldwide basis by 2021 or 2100 or however, whatever the target is, given the goal of reducing poverty?
Reducing what?
Poverty.
The role of poverty and
it's the competing goals of reducing poverty while also dealing with the climate change.
With reducing carbon emissions. So the role of poverty in reducing climate emissions. Does anyone want to tackle that? Yes?
I'll go ahead and start. So as I introduce the concept of sustainability to entering freshmen, we make the argument that's gotten the acronym of the IPAT equation, that impacts are a function of population, which we've heard about in questions so far today, then affluence, poverty, and then technology. So population's going up by 1% to 2% per year. Affluence per person is going up by 3% to 5% per year. And so you couple those two together, and that means that the drivers of consumption are going up by on the order of 5% per year. And if I'm speaking to an audience of engineers, I say that's our challenge, just to stay even. We need to improve our efficiency, the efficiency of resource utilization in our technologies, by 5% a year, just to keep pace, given that we don't want to sacrifice the ability of people to pursue affluence, to get out of poverty and facing the realities of population. So it's really a driver for us as engineers, but the affluence driver is double what the population driver is, just in terms of growth and consumption.
Interesting.
Maybe I could add just a little. First of all, I don't think we can put the burden on addressing climate change to the low-income community around the world. I know you're not saying that, but I think the burden of reducing emissions is on the affluent people in the world. Right? So that's number one. And that's all of us, the global north, et cetera. And within the global north, there are people who are marginalized communities, and the burden should not be on them. number one. Number two is that for those people below the poverty line internationally, they don't have infrastructure to access electricity or clean water, etc. The infrastructure is inaccessible or unaffordable. And I think that's where the opportunity is to help them leapfrog into the 21st century, as opposed to some of them in the 19th century right now. So I think the two things out here: decarbonize our economies that are producing and have produced the emissions, and then help other countries leapfrog into new infrastructures and technology that are clean. And I always say this, that if addressing climate change does not improve the quality of life of those people in the poverty, in a poverty regime, and bring them out of poverty, it'll be very hard to achieve what we're trying to do, because the people will not accept it. It has to improve the quality of life of people around the world.
Yeah, I'll add that again. It goes back to our discussion on having a social planner or some global organization that helps us get there. There are a couple comments I have there. One, I think we have a lot of carrots. We have to make sure that they're not wasteful. Second, we talked about creative destruction. I think we need to have policies that take care of the impacted populations. When you look at the integrated assessment models, they are all at the population level or GDP level, but not really considering distributional impacts of these policies. For example, if we follow through and come up with a carbon tax, it will basically flow through to the product prices, right? So everything is expected to be more expensive. Beef consumption, right? That's expected to be more expensive. So that's going to impact how low-income populations spend their money on what they have to spend on. So we need to have social policies in place to take care of the people who are disproportionately impacted by the change. And that needs a lot of policy and planning, I think.
Sarah, you want to comment?
I would also add, without dealing with climate change and having increased magnitude of events and probabilities of events, you also put people into poverty. You either put them into poverty because a massive event takes out all the infrastructure and then everyone has nothing. Like, we even saw this last summer in Pakistan, where the floods left a sixth of the population displaced as a result of it. I will also add, in the climate security circles, there's discussions also, and in discussions of if you play out what happens as you have worsening climate change and habitability starts to become a problem in certain parts of the world, you also start to have migration. You have places that either due to lack of food, lack of water, lack of infrastructure, where people will just leave because they won't be able to live in those places. And so there ends up being a redistribution of where people are around the world as a result of that. So without dealing with these problems, the poverty problem actually becomes worse.
Great. So I know that we have more questions, but we actually are getting towards the end of time. So I just want to say thank you for all of you for having so many wonderful questions. And I know it's really important to ask the tough questions, to have the tough conversations. I'm sure our speakers will be available after if those of you that are standing might want to ask your questions directly. But at this point, I think we're going to start wrapping up. And today we're talking all about sustainability, measuring and communicating our progress. And I think we've heard that it's very complex. There are so many different aspects to this. And I think above all, we're hearing that it's urgent. It's extremely urgent. So I would just like to invite all of our panelists to just end with, your closing remarks, speaking to the urgency of this, and I think also, encouraging our members here and what they can do to help collectively, work towards a more sustainable future. So we're going to start. Do you want to start here?
Sure.
Yeah, go ahead, Sarah.
So I guess in closing, I'll say for everyone going back into their jobs, I actually think that every single job can have a sustainability component. I've seen that from working at NOAA. I've seen that from working in the private sector. And so if you think about what your operations are or the work that you do, there are ways to incorporate how to think about sustainability in your job that then advances it forward. And so I task you to think about it, because if we really do believe that this is going to be the innovation of the future, there's tremendous opportunity to make progress on this, even in our individual work.
Thanks, David.
Well, I'd like to speak specifically to this room. There's been a lot of talk about credibility of information, dissemination of information, getting broad support. And what is desperately lacking in a lot of these discussions is a trusted voice. And we're now all part of the academies, many newly inducted. And so the academies is one of the few remaining trusted voices. So if asked to serve on a massive decarbonization study or review a 500-page report or further enhance the Academy's role as a trusted voice, please do so.
Great. Erkan.
Yeah, I mean, I'll mention that today we are thinking that some information is better than no information, meaning we are all operating under the assumption that whatever's available is going to help us make the right decision. But I think over time, and this relates to understanding our emissions, understanding our water consumption or energy use. Over time, I think we want more precision, so we make better decisions as individuals and employees and companies, and I think it needs everybody's help with that.
Well, first of all, I want to thank the National Academy of Engineering and the leadership for highlighting this issue and picking this as a topic. And I think we should all be thankful to the National Academy of Engineering for doing that. I think one thing I would say is, based on the discussion, it is clear that the behavioral side of it is something that we haven't quite paid enough attention to, or we may have paid attention. We need to figure out mechanisms to get people on board. And how we do that, whether it's social networking the right way, I'm not the expert, but I think that has been highlighted out here. And I think if you could pay attention to that, that will go a long way. I think in addition to the decarbonization side, which we talk about a lot, I think we need to elevate the issue of climate adaptation and protection of our communities. Because we run the risk of going beyond global average temperature rise of 2 degrees, and we're not quite sure what that is going to be, 2.5, 3, but we know it's going to be worse than where we are today. That is, and we don't know exactly where the climate events are going to hit unless NOAA and others figure out subseason modeling. But the adaptation part is a global issue. It's certainly a domestic issue. And I think the underserved communities are going to get worst affected by this. And we need to figure out mechanisms to protect people during this transition.
Great, thank you so much. So I just want to say thank you to Sarah, to David, to Erkan, to Arun. Thank you so much for being here. Please join me in giving our appreciation. It's been insightful, it's been informative, and the action doesn't stop here. So I'll pass it over to Al, who's going to transition us out.
So let me reiterate on behalf of the NAE, Arun, David, Sarah, Erkan, thank you for such an informative, forward-thinking discussion of one of our nation's most timely issues. And thank you, Deanne, for your expertise in moderating the discussion. The discussion day here will certainly help propel us forward into effective, positive change. Thanks again to our annual meeting program committee and committee chair Ann Roby, the staff that supported it, and now it's time to adjourn to lunch in the tent unless you have another side meeting scheduled. I know there are some. And I think everyone knows how to get to the tent. Great Hall, make a right turn, and if all you'll know is you'll end up there. If you did register to attend the Women of the NAE lunch, that's held in the lecture room, which is in the East Court. So go out to the Great Hall and go left up the steps, and you'll see it off there to your right. So either one of those. And with that, we'll see you all in the section meetings this afternoon. Thank you.